Hello and welcome. This is the presentation for a study on real-time classification approach for rumor detection. My name is Muhammad Abu TALHA IBNA RIAZ HASSAN. My matric number is A20EC3022 and this is my PSM1 presentation video. Introduction. In recent times, the shift from traditional media to social media as the primary news source has brought about challenges related to the credibility and rapid dissemination of information. The prevalence of false news on social media platforms poses a significant threat due to the absence of rigorous verification process. The traditional time-consuming procedures employed by traditional media are not applicable in the fast-paced and user-generated content landscape of social media, where the risk of spreading false information is notably high. This has led to the emergence of real-time rumor detection as a potential solution, involving immediate and continuous monitoring using machine learning and deep learning techniques to swiftly counteract the spread of rumors or misinformation. However, implementing real-time rumor detection on social media platforms faces challenges, with current initiatives being limited and sometimes insufficient. So the research aim, question and objectives of my research are as follows. The aim of this research is to develop and evaluate a real-time rumor detection using CNN, which is convolutional neural networks, in conjunction with ontology, with the goal of enhancing the accuracy and precision of rumor classification compared to the existing methods. The research question for my project is, what impact does the integration of CNN with ontology have on the effectiveness of real-time rumor detection compared to traditional methods? The objectives of the research include designing classification system for rumor detection using CNN, to design ontology-based CNN for real-time classification of rumor detection, to evaluate the performance for the approach design. The research scope of my research is as follows. First, we will collect the data source. The primary data source of this study will be from social media called Twitter, which is also referred to as X. CNN-based rumor detection in this study will be implemented as well. Ontology integration. We will focus on integrating ontology technology with the CNN-based rumor detection system. The integration aims to enhance accuracy and efficiency by introducing a structured framework for data analysis. Performance evaluation. The research will systematically evaluate the performance of both the CNN-based approach and the ontology-based CNN approach. Evaluation metrics such as accuracy and precision will be employed to measure the effectiveness of these systems. Overview of my literature review. In this section, we will provide an in-depth exploration of the realm of rumor detection and classification, starting with the concept of rumors as potentially untrue stories. The chapter establishes the groundwork for understanding how rumors are recognized and categorized. The focus then shifts to various techniques and algorithms used in rumor detection, providing a simplified explanation for practical comprehension. This chapter also delves into the discoveries made by other researchers in this field, analyzing previous studies to gain insight into effective and less effective practices. Overall, this chapter serves as a guide connecting the conceptualization of rumor detection with practical methodologies and the underlying technology. Rumor detection involves determining the truthfulness of information, considering factors such as data collection, documenting rumors within the specific time frame, and acknowledging the origin of a rumor. Research on automatic rumor detection has gained popularity, especially with the significant role of social media in propagation of information nowadays. How is rumor detection done manually versus automatically? Manually, we do it by collecting potential relevant documents, analyzing each document, estimating trustworthiness of documents, and then finally decision making based on aggregation, meaning aggregate results from stance forecasting and trustworthiness estimation to reach a conclusion about the accuracy of the initial claim. And by automatic rumor detection system, we mean when we make systems that can classify rumors using machine learning and deep learning. Using algorithms and models that flag content with characteristics indicative of false or misleading information, these approaches of rumor detection are used. The approaches are mainly machine learning, deep learning, and hybrid approach, where the tweets, news, and messages are then inserted into one of these three models, and then we can get a binary classification of are these tweets, news, or messages a rumor or not a rumor. Machine learning. Machine learning uses input, feature extraction, classification, and output. There are two types of approaches in machine learning method. Supervised based approaches, which use labeled data sets to train the models to distinguish between confirmed rumors and non-rumors. And unsupervised approaches analyze patterns within data without predefined labels, focusing on anomalies or clusters that may indicate potential rumors. Deep learning. Deep learning uses input, feature extraction, and classification, and then it gives out the output. There are the most common and famous approaches for deep learning are CNN-based approaches and RNN-based approaches. CNN-based approaches analyze images and text to identify patterns associated with false information. RNN-based approaches focus on the sequence of information and capture dependencies over time. And finally, we have the hybrid approach, where we can just combine different methods to enhance overall efficiency, aiming for better results by leveraging the strengths of each method. Here are some of the studies that are done by researchers in this field, where we can see that machine learning gives an accuracy of 86% or 77%, so the range is between that. Deep learning gives about 84% to 86%, and if we use hybrid methods, we get really staggering results of 92% and 89%. Can ontologies provide better results compared to the current methods that are used? Yes. Ontologies can improve real-time rumor detection by establishing a common language for communication and facilitating smooth cooperation among various entities involved in the process. So, for my research methodology, I have done the following. Research methodology is the systematic and methodological approach used by researchers to conduct studies or investigations. It serves as a roadmap outlining methods, steps, tools, and procedures to gather, analyze, and interpret data for addressing specific research questions or testing any hypothesis. So I have done all this. The significance for this is it is critical for achieving research objectives and overcoming identified problems, and it also acts as a guide for how the research will be executed. So my research workflow looks like this. First, for objective 1 of my research, which is to design the real-time classification for rumors detection using CNN, I have collected the data and then done some data pre-processing and then made the CNN model architecture and then implemented this CNN model. After that, for my PSM2, objective 2 and objective 3 will be achieved. In objective 2, we will design an ontology-based rumor detection where we combine the ontology with the previously made CNN model architecture. And for objective 3, we will evaluate the performance of the approach design to check and see if this ontology-based rumor detection is better than the current approaches used in this field. Performance measurement metrics. The performance measurement metrics that I will be using for my research is accuracy and precision. Accuracy is the overall correctness of the system's classifications, and reliability is and precision is the reliability of the system in correctly identifying rumors among instances labeled as such. The formula for accuracy and precision are given here. Dataset insights. The dataset I have collected is from Twitter. This was sourced from Kaggle through Fake News Net and is available in a CSV format. The key attributes in my dataset are title, news URL, source domain, tweet number, and the label column real, which binarily classifies if the tweet is real or fake, if the news is real or false, where 1 indicates real and 0 indicates fake article. Dataset significance. I have chosen these datasets for its relevance to fake news detection. The title column used as the feature variable X during CNN model development, and real column used as a target variable for binary classification of articles. Data pre-processing steps. For my data pre-processing, I started with first loading the dataset in the CNN model, and if there are null values present, we drop the missing or null values. If not, we straightly go to extract text from data. After that, we do some data tokenization where we convert the text data into integers. And after that, we pad the data so that every integer is of same length. Then we do the train test data split for k-fold cross validation. After that, that will be the end of the data pre-processing for my research. CNN implementation. I have implemented k-fold cross validation, and I have implemented 5 folds to maximize model reliability. Train and test data split for each fold. CNN model architecture. There are a total of 4 layers in my CNN model architecture. The first one is the embedded layer for converting integer encoded words into dense vectors. Then I have implemented the conv1d layer for local pattern extraction. Then I've implemented global max pooling 1D layer for spatial dimension reduction. Dense layer for binarily classifying real or fake news. Here you can see the CNN model architecture. So the input or the text pre-processed text data is first gone into the embedded layer, then the conv1d layer, then the global max pooling layer, and then in the dense layer we finally classify if the input is real or fake, and then we get the output. So after making the CNN model architecture and after implementing the CNN, we get some accuracies and precisions. Since I have done k-fold cross validation, I will get 5 precisions and 5 accuracies for each fold. And the table for the accuracies and precisions achieved from running the CNN models are given here. The average accuracy I've gotten is 82.76%, and average precision I've got is 87.12%. We can say that the CNN model for rumor detection achieved good results across multiple folds, demonstrated high accuracy and precision, contributing to the success of the approach. My next milestone will be to integrate the ontology with CNN and see if that method increases the accuracy and precision of the CNN and also of the other methods that are used in the field today. Thank you. This has been my PSM 1 presentation video. Assalamu alaikum.